Okay, so I've got like a super easy one and kind of one that's not so much here. Okay, so let's look at 13. Okay, so a block slides down from rest with negligible friction, the track above descending from 0.5 meters to point P. So this, see, you can see it says mu equals 0, this whole area, no friction. However, in this area, I haven't read the question, spoiler alert, there's friction, because that's what there's mu equals 0.2, 0.2. Okay, so the block slides there. Okay, then slides on the horizontal. So this is totally horizontal surface. The coefficient of friction, the horizontal is 0.2. How far does the block slide on the horizontal before it comes to rest? This is like completely evil and beautiful problem, but it's one that you might not sink too much time into. I should probably come back and explain it, but I'm going to do it here as fast as I can. Okay. First and foremost, this is going to end up, look, let's just write what's happening. You've got potential energy, you've got kinetic energy, then you have a whole bunch of work due to friction, okay, on the system, to where it basically loses all of its energy in sub-zero here. So basically, what you're going to have is your work due to your work energy theorem. Let's change in energy. So by the work energy theorem, you're going to have work equals mgh, because all of this is getting converted into this work. All right, so that's your work. Now, oh God, m, they don't tell us m, oh my God, don't worry about it. Look at how else you can write work. Work is also your force dot displacement, right? Okay, we're looking for the displacement. What force is acting on it? Well, since this is the work of friction, that is the force of friction. If you'll recall, force of friction equals mu times your normal force. Well, let's look at your normal force. If we just have a box sitting here on this like frictiony surface, let's look at your up and down and be weight, because it's not accelerating in the y direction. So that's weight and your normal force. So therefore, force of friction equals mu times your weight. So we can put all this together. And therefore, big therefore, mgh equals, I've seen this more in free response questions, that's why I'm taking time with it, equals mu mg. Okay. Times displacement. Mg goes away, therefore your displacement equals h over mu. Now your h is 5, and that is going to be divided by 0.2, right? And I am going to be weak and bring the calculator because it is late at night. 5 divided by 0.2 equals 25. Yay, that's one of the answers, and it happens to also be the right answer. E. Okay, now for the not so hard one. Let's look at this. 14. It looks ridiculous like an ice cream cone, but the graph above shows the velocity as a function of time for the object moving along a straight line. So we've got an object moving like just a straight line, but it's speeding up, slowing down, it's accelerating, and you know, whatever. Okay. For which of the following, see, this is what makes it awesome. For which of the following sections of the graph is the acceleration constant and non-zero? Let's get rid of your zero ones first. Remember, the slope of a velocity versus time graph, dv over dt, is acceleration. So these are zero. Eliminate these. Okay, so we want constant. See how that does that? It's not a straight line. Not constant goes away. So we have rs and st. D is your answer.